So for your 3.3, we have variation of resistance with temperature. So kita nak tengok how does your resistance vary with temperature. Okay, so kita ada dua learning objective here. Explain the effect of temperature on electrical resistance in metal and also use the equation R is equals to R naught bracket 1 plus alpha bracket T minus T naught close bracket. Okay. Alright, so first thing adalah we are going to look at the effect of the temperature on electrical resistance in metal. Kalau kamu tengok dalam learning objective kamu dia cakap kita nak tahu on metal sahaja. And as you can see in your notes, I have given 4 metal. Ini yang kita nak wajib tahu for semiconductor and also superconductor. Untuk semiconductor dan superconductor, you do not have to know, tapi saya bagi sebagai extra knowledge here so that you can compare and understand the difference between this type of material dekat sini. Okay, untuk awak boleh tengok perbezaan lah dekat sini. Untuk metal, semiconductor dan juga superconductor kamu. So this is the 2 points that you have to know for the first learning objective. Alright, so the electrical resistance in metal is always increases with increasing temperature. So maksudnya as your temperature increase, your resistance will increase. Okay, they are directly proportional. When the temperature increases, saya nak explain kenapa bila temperature increase, resistance akan increase ya. The number of free electron per unit volumes in metal remains unchanged. Okay, so katakan ini metal kamu dekat dalam ni, so as you heat up, maksudnya temperature kamu, temperature dekat luar ni berubah. Okay, so the number of electron per unit metal ini, nilai nak bilangan dia tidak akan berubah, dia remain unchanged. However, the metal atom in the crystal lattice vibrate with greater amplitude. Cuma all these lattice now is going to vibrate with greater amplitude. Maksudnya akan berlaku perlanggaran antara elektron kamu dan juga dia punya surface dekat sini with a greater amplitude, and this causes a greater leads to increase in the metal atom. Okay, number of collision dia akan increase sebab bila perlanggaran dekat sini lebih banyak, kamu punya resistance akan increase because current will find it difficult for it to pass through as there is too many movement occurring at the same time. Okay, so particles kamu ini free electron ini akan berlanggar dengan kamu punya crystal lattice permukaan dia yang tengah vibrate vigorously, which is going to cause an increase in the number of collision. Therefore, your resistance here is going to increase. Okay, so jangan salah faham by increasing the temperature, the number of free electron is going to increase. No, number of free electron tidak akan berubah, dia masih unchanged. Cuma vibration of the crystal lattice becomes bigger. Vibration dia becomes bigger, dia akan ada getaran yang lebih banyak. Bila getaran dia lebih banyak, it's going to cause the number of collision between the free electron and the metal atom to increase. So elektron yang dekat dalam ni akan mengalami perlanggaran yang lebih banyak dengan dia punya surface dekat sekeliling ini, which causes the resistance to increase. Itu satu-satunya reason why does your resistance increase when your temperature increase. So soalan ini boleh jadi dia tanya dalam soalan UPS kamu. Sebab UPS adalah C1, C2. Ini soalan konsep dan ini adalah kamu punya learning objective untuk subtopik ini. Okay, it's not that the number of free electron increase, it's just that number of collision between the free electron and metal atom increase. Itu sebabnya. Alright, so untuk semiconductor dan superconductor, awak boleh baca sendiri dan fahamkan. Okay, now we're going to look at a new term introduced in this subtopic, iaitu temperature of coefficient of resistivity, alpha. Okay, the temperature coefficient of resistivity is the ratio of the change in the resistivity of the material, change in the resistivity of the material due to the change in the temperature of 1 degree Celsius to its resistivity at 20 degree Celsius. So, Ini basically adalah ratio of the change in the resistivity to the change in the temperature. Okay, so equation dia by equation pula alpha dia, which is coefficient of resistivity, adalah 1 over R naught. R naught ini adalah resistivity at a reference temperature. Okay, naught ini indicate reference point kita. Reference point ini always occur at 20 degrees Celsius. Okay, ini sepatutnya ini adalah secara scientifically it should be at 20 degrees Celsius, because when you want to prove and also to identify the value of alpha ini, the experiment was conducted at 20 degrees Celsius. So ini adalah reference point kita. Okay, however dalam syllabus kita, kita ada tendency untuk tidak menggunakan dia at 20 degrees Celsius. So kita akan bagi temperature yang lain-lain jugalah. Okay, so awak tak payah risau because you're just going to calculate the value here, so you can simply use whatever given in the question. Tapi secara asalnya this equation is only valid for the resistivity at reference temperature, iaitu 20 degree Celsius. 1 over rho, resistivity at 20 degree Celsius, reference temperature normal. And then ini adalah change in the resistivity. So as your temperature is going to increase, resistance berubah. Okay, temperature increase, resistance berubah. Kenapa? We have already looked at it based on these two sentences dekat atas ni, kita dah faham. Okay, and then according to the equation, resistivity sama dengan RA over L. Okay, if the area and the length is kept constant, resistivity is directly proportional to the resistance. So kalau resistance sesuatu material itu increase, resistivity dia pun ada tendency untuk increase. Okay, because they are directly proportional. So when your temperature increase, resistance increase, indirectly resistivity pun akan meningkat. So when your resistivity also increase, kita akan ada difference in the resistivity, iaitu resistivity at temperature 20 degrees Celsius pada permulaan eksperimen lah contoh. And then after you increase the temperature, temperature berubah, kita akan ada resistivity yang baru at a new temperature. So this is delta V kamu, delta rho kamu, which is the difference in the resistivity, bahagi dengan difference in the temperature, delta T. Okay, the difference in the temperature, initial temperature, and then you rise it to another new temperature. Unit untuk alpha ini dikenali sebagai degree per Celsius ataupun Kelvin per Celsius. Kelvin negatif 1 dekat sini, K negatif 1 ataupun T negatif 1 dekat sini. Ini adalah unit untuk alpha. Because the resistivity punya unit they cancel each other, you are left with unit from the temperature sahaja. So your temperature dekat sini boleh in degree ataupun boleh in Kelvin sebab kita nak difference in the temperature sahaja. Okay, because you are talking about delta T, perbezaan dalam temperature dekat sini. So if I were to rearrange this equation, saya akan dapat equation yang ini. Okay, macam mana kita rearrange adalah kita kembangkan semua benda dekat sini, iaitu such as alpha is equals to 1 over rho naught. Delta rho adalah rho at new temperature minus rho at reference temperature kita, bahagi dengan T naught. Okay, so lepas kita kembang, we do your math, awak bawa ini ke sini, and then awak pun bawa lah rearrange apa semua bagai, you will end up with rho, iaitu resistivity at a new temperature ataupun temperature lepas kita increase itulah selalunya, is equals to rho naught 1 plus alpha T minus T naught, where rho is the resistivity at T, rho naught adalah resistivity at T naught. Okay, T naught adalah reference temperature kita. T adalah any other second temperature yang dia akan beri. Okay, since R is directly proportional to the resistivity, ini saya dah tunjuk berdasarkan equation yang kita tengok dalam video semalam, rho is equal to RA over R. So they are directly proportional. So this equation can also be written as resistance is equals to R naught bracket 1 plus alpha T minus T naught here. So ini dua-dua equation yang sama. It's just that when given the information on resistivity for different temperature, you can use the first equation. If given resistance, you use the second equation. Itu sahaja. Beza dia dekat sini. Okay. And then R adalah resistance at T, where T is the second temperature yang diberi dalam soalan. R naught adalah resistance at reference temperature. And then alpha here is the temperature coefficient of resistivity ataupun coefficient of resistivity. Okay, so this is the equation yang dimension dalam second learning objective kita, where you have to be able to use this equation. Alright, okay, cuma saya nak tekankan T naught ini selalunya lah dalam soalan macam saya cakap, sepatutnya dia adalah 20 degree Celsius. However, dalam syllabus kita tak semestinya akan guna 20 degree Celsius. Yang penting dalam soalan akan ada dua temperature. Okay, T naught adalah temperature yang paling rendah. Sentiasa you take the smallest temperature as your T naught. Yang rendah itu yang kita akan jadikan sebagai reference temperature. So this reference temperature is also known as the lowest temperature. So temperature yang paling rendah. Okay, kadang-kadang dia akan guna temperature 50 dan juga 100. So yang paling rendah dekat sini adalah 50. So that 50 degrees Celsius will act as your T naught, reference temperature sekarang. Okay, so choose the lowest temperature as your T naught. Okay, we do one example together here. What we have here is a certain resistor has a resistance of 1.48 at 20 degrees Celsius. Okay, and a resistance of 1.512 at 34 degrees Celsius. So as you can see, you have two temperature here. One is 20 degrees Celsius and another is at 34 degrees Celsius. And also you have different resistance for different temperature. Untuk 20, 1.48. Untuk 34, you have 1.512 ohm. Okay. So this directly proves that when the temperature increase, the resistance is also going to increase. Okay, so temperature yang kita ada 20 dan juga 34. So 20 yang paling kecil, so 20 will act as your T naught. So since 20 is T naught, the resistance at 20 degrees Celsius is your R naught. Okay, and then you have second temperature kamu, ini adalah T kamu, this one becomes your R naught. The temperature coefficient of resistivity. So soalan nak alpha sekarang. Okay, so to find alpha, kita boleh guna equation yang kita baru belajar dekat atas ni, iaitu this one. You have alpha here, dalam equation ada alpha, ini yang kita nak cari. Resistance at a certain temperature given. Resistance at reference temperature is also given. Semua informasi ada. Tinggal nak masukkan nilai sahaja. R equals to R naught 1 plus alpha T minus T naught here. Okay, so R kamu adalah 1.512. R naught adalah 1.48. Jangan salah substitute. The lowest temperature is your naught here. Okay, lowest temperature adalah naught kamu. So for that particular temperature, R dia akan jadi R naught. 1 plus alpha, this is what we are looking for. T adalah 30.
So where were we tadi? Oh, we were discussing the question. Okay, what is left here adalah for you to press your calculator and then you can get your alpha here. Boleh dapat alpha terus. Tekan calculator, dapatlah this as your alpha. Remember the unit adalah -1 ataupun K -1. So since dekat sini awak guna dalam Celsius, so kita ambil C -1. Are we all good?
Yes, Miss.
Yes, Miss.
Okay ke? Tolong respon kalau tak saya rasa macam saya tengah bercakap
Okay, Miss.
berserang-serang.
Okay, Miss.
As if I'm not connected. Okay, saya tak buka volume pula. So we are good, right?
Yes.
Yes,
Okay.
Miss.
So itu adalah for 3.3. 3.3 is a very small subtopic. Ini. awak do the remaining example here. Resistance and also potential. What you have to know here, you have 4 learning objectives. Equation V is equals to EMF minus IR. Okay, first thing adalah we are going to look at the definition of EMF and also internal resistance. So, electromotive force, EMF, is defined as the energy provided by the source. Source dekat sini adalah usually the power supply, battery ataupun cell ataupun apa sajalah. To each unit charge that flow from the source. So let's say you have a circuit. Dalam circuit kamu ni kamu akan ada ini. Ini kita panggil dia sebagai power supply. Okay, dia sebenarnya adalah your battery. Okay, so the energy provided by the source, which is your battery ini, to each unit charge that flow from the source is what we call as electromotive. Sebenarnya awak dah pernah belajar pun benda ni, cuma kita panggil dia sebagai potential. Okay, awak panggil dia sebagai volt. Voltage daripada bateri itu kan volt. Tapi nama sebenarnya dia adalah electromotive force. We have been using another name dekat sini iaitu voltage ataupun potential sebab kita sebelum ini kita neglect the term internal resistance. So now you have reached a point where you should know regarding the internal resistance. Maka kita belajar term betul lah. Ini dipanggil sebagai EMF. Internal resistance is defined as the resistance of the chemical inside the cell battery between the poles. So you have your battery here kan, ini bateri kamu. So the chemical between the poles here, alright, the chemical between the poles here will gives you resistance. Okay, dekat dalam tu kita akan ada resistance. Okay, kalau kamu belajar kamu punya chemistry dekat sini, so kamu akan ada buat eksperimen. Dalam eksperimen, if I'm not mistaken, yang masukkan dalam solution tu kan, anode dengan cathode tu kan. So from there tu sebenarnya kamu boleh faham konsep inilah kan. So you will have the resistance in the chemical. This is what we call as the internal resistance, iaitu resistance yang wujud di dalam bateri kamu, iaitu your power supply ni. Okay, so resistance ini, internal resistance ini di dalam EMF sebenarnya. Okay, it is present in the EMF. Okay, the factors that influence the internal resistance. Okay, ini adalah faktor-faktor yang akan affect your internal resistance, iaitu the distance between the electrodes directly proportional. So, think electrolysis. Okay, electrolysis tu kamu akan ada masukkan kamu punya kaki cathode dengan anode dalam solution tu kan? Yes, okay. So the distance between the electrodes here indicates the will affect your resistivity. Contohnya, if the distance between the electrodes are greater, you are going to have greater internal resistance because they are directly proportional. So as your D increase, your internal resistance is going to increase juga. And then the surface area of the electrodes in the electrolytes. Okay, dalam cecair ini, dalam your solution here. Okay, so the surface area, the more area is exposed to the electrolytes, the lesser the internal resistance is. They are inversely proportional. So the surface area yang exposed to the electrolytes are inversely proportional to the internal resistance. And then the temperature of the electrolyte. So when you conduct the experiments ini, so if the temperature here changes, it is going to affect your internal resistance. However, they are inversely proportional. Dia tak sama macam kamu punya yang kita cakap dekat atas ni temperature increase, resistance increase, ini adalah resistance yang berada di luar bateri, iaitu yang wujud di dalam circuit. In a circuit, okey, bentuk dia adalah begini, ini circuit, ini bateri. Ini adalah R biasa, resistance yang berada dekat luar. Okay, ini kita panggil external resistance. Now we are talking about the resistance that is present in the battery. Okay, and your battery consists of these electrolytes dekat sini. So the temperature of the electrolytes is inversely proportional to the resistance. The greater the temperature of the electrolytes, the smaller the resistance, internal resistance would be. And then finally is the concentration of the electrolytes. If your electrolytes is so concentrated, the internal resistance will decrease. They are inversely proportional. So awak kena tahu kesemua faktor ni and how they react, whether they are directly proportional or inversely proportional. Okay, and then so sekarang kita nak tengok pemahaman kita on terminal potential difference, iaitu the next term dekat sini, ataupun potential difference across the battery terminal. Okay, before that you have to understand your circuit dulu. Consider a circuit consisting of battery that is connected by wires to an external resistance R as shown in the figure. So ini adalah bateri kamu So this is your battery. Dalam bateri kamu ni kita ada dia punya kaki positif, kaki negatif, and then you are going to have your internal resistance. This one is present inside the battery actually. And then kita ada wire, and then you have resistance which is known as external resistance that connects to the circuit here. Okay, a current I flow from the terminal A to terminal B. Maksudnya akan keluar daripada kaki positif. From terminal A, it goes to terminal B. Dia akan sampai balik B. Okay, current yang keluar ni adalah current yang keluar daripada EMF ini. For the current to flow continuously from terminal A to B, a source of electromotive force, EMF, is required so that the battery can maintain the potential difference between A and B. Okay, so kena ada EMF untuk maintain the potential across A and B ini. Okay, now kita nak tengok apa itu potential across A and B. Itu potential from here to here. Okay, potential across terminal A to terminal B. Okay, this is known as terminal potential. Okay, sebab dia adalah potential pada bahagian terminal kita. Terminal dekat sini adalah, this is the terminal that we are talking about lah. Is defined as the work done in bringing a unit test charge from point B to point A. Okay, kenapa from point B to point A adalah, it is the work done to bring a unit test charge. Dalam chapter 2, waktu kita belajar pasal charging discharging capacitor, I have talked about when the current is flowing from positive plate to negative plate, at the same moment, electron will flow from negative to positive carrying the charge. Dia akan carry the charge. So dekat sini dia tengah cakap potential from A to B ni, potential difference AB ni, terminal potential ini is the work done to bring charge, iaitu charge electron ini from B to A. Point B to from point A. You're trying to bring the electron from point B to point A ini. Okay, this is what we call as terminal potential difference. Terminal potential difference ini, it has nothing to do with the current that is going to flow across the internal resistance. Okay, dia tak ada kaitan. Dia hanya lalu dekat bahagian luar sahaja dan dia lalu resistance yang di luar sahaja. Dia tak ada kaitan langsung dengan resistance dekat dalam sini. Okay, so EMF is whatever that has been produced secara total. Okay, the battery is going to produce, let's say 5 volt. Ini adalah paling total. Okay, 5 volt ini is the total amount ataupun as you can see by the definition adalah energy provided by the source. Okay, this 5 volt has to go across the internal resistance dan juga external resistance. Sebab current daripada sini, dia keluar, dia pergi, dia lalu external resistance, dia datang, dia akan lalu internal resistance juga. Okay, so it has to overcome this internal resistance and also external resistance. So this 5 volt belongs to both the resistance here. Okay, however, terminal potential difference, untuk terminal potential difference, dia hanya akan lalu external resistance sahaja. Dia tak ada kaitan dengan internal resistance. So at this particular point, you must be very clear, EMF kamu tidak sama dengan terminal potential. Untuk terminal potential, kita guna V subscript T lah. Supaya kita senang faham, supaya kita tak buat kesalahan, kita guna subscript T dekat sini to indicate it's a terminal potential. Alright, when the current I flow naturally from the battery, there is an internal drop in the potential difference. Okay, bila dia flow daripada battery, dia akan ada drop in the potential difference equals to IR. Drop in disebabkan oleh current akan lalu this internal resistance. Thus, the terminal potential difference VAB is given as apa saja yang akan lalu AB ini, apa saja current yang akan lalu AB ini adalah after you have passed through the internal resistance. So, terminal potential difference iaitu V yang kawan ini akan baca. V ini tidak sama dengan 5 volt. Okay, dia tidak sama dengan 5 volt. It is not 5 volt even though your battery has 5 volt voltage. Okay, dia tak sama. Dia adalah whatever remaining after the EMF has given the internal resistance. Okay, so V dekat sini adalah terminal voltage. Terminal voltage is equals to the total from power minus the current that passes through the internal resistance. Sebab current yang passes through the internal resistance also give you potential. Okay, V is equals to IR adalah Ohm's law. So kalau dia across internal resistance, so voltage dekat sini adalah across internal resistance punya. So basically what happen dekat sini adalah apa yang kamu kena faham. Sekejap saya nak tambah kertas. When you have a circuit, this is your circuit. Okay, ini bateri kamu. So kalau dia letak simbol R kecil, contoh dia tak lukis bentuk bateri ni sekalipun, kalau dia letak simbol R kecil ini, this indicates that the battery, the resistance that is present in the battery, resistance di dalam battery. This is what we call as internal resistance. Okay, so whatever potential you have from the power supply EMF ini, okay, katakan dia adalah 10 volt, this 10 volt has to go through this internal resistance. Selepas dia limpas internal resistance, yang remaining itu baru akan keluar, pergi lalu ke external resistance, datang balik ke sini. Okay, so whatever that goes out ini, kita panggil dia terminal potential difference sebab dia lalu dekat terminal sahaja. So basically EMF adalah total potential campur dengan potential across the terminal yang dekat luar ini, campur dengan potential drop across the internal resistance. Okay, so kalau saya rearrange, V terminal akan jadi EMF tolak dengan V across internal resistance. V across internal resistance adalah current yang akan lalu internal resistance itu. So basically V terminal ini pun adalah sebenarnya current yang lalu external resistance. Kalau kamu ada dua resistance dekat sini tak ada masalah juga. Dia akan jadi external resistance yang total. Iaitu R ini, R1 dan R2 in series. So kalau resistance in series, kita campur. Okay, series resistance tadi tu. Kita guna simbol S. Okay, so EMF kamu adalah sebenarnya adalah I, R besar campur dengan I, R kecil. I besar ini saya factorize, dia akan jadi R plus small r. So indirectly what happen here is the same current will pass through your external resistance and also internal resistance. Okay, current yang sama yang akan lalu dua-dua. Cuma mula-mula dia akan lalu dalam bateri ni dulu, dia akan overcome this potential, dia akan overcome this resistance and then the remaining itu baru dia akan bagi dekat kamu punya terminal. Just in case dalam soalan dia kata neglect the internal resistance. abaikan internal resistance. So bila kita abaikan internal resistance, dia seolah-olah tidak wujud. So bila tidak wujud, current takkan lalu internal resistance. So when there is no current passing through internal resistance, kita tidak akan ada drop across the internal resistance. So potential drop across internal resistance ini akan jadi kosong. So bila kosong, in that particular case, kita punya EMF akan sama dengan terminal potential. Okay, ini yang kamu belajar selama ini. Okay, kamu belajar power supply itu kita panggil dia V. Okay, sebab all this while we have been neglecting the presence of internal resistance. Okay, sekarang you have come to a level where you should now know the presence of internal resistance. So bila kita consider internal resistance, kita take note kalau wujud internal resistance dalam bateri, okay, apa yang dia kena overcome dulu internal resistance, maksudnya dia kena overcome dulu masalah dekat dalam dia, baru dia boleh bagi dekat orang lain yang remaining. Okay, so whatever goes to the terminal is always less than the total you had here. Okay, dia mesti kecil daripada yang total. So ini kena paling besar lah sebab dia nak bagi untuk external resistance dan juga internal resistance. So you can use this equation ataupun this equation juga, tengok apa yang dia nak minta current, kita kembangkan. Kalau dia tak nak current, kita boleh terus guna equation V terminal is equals to EMF minus IR. Yang kamu kena faham sekarang, bila internal resistance is present, apa sahaja daripada bateri kita tidak akan sama dengan apa yang akan lalu dekat terminal. They are not the same. Your EMF is no longer the same as your V terminal due to the presence of internal resistance. Are we all good here? Jelas tak?
Yes, miss.
Ada soalan? Ada soalan? Tak ada? Okey, kalau tak ada soalan, itu sahaja untuk electromotive force, internal resistance dan juga potential difference.